Welcome to another teardown and test video. This time it's a radiometer, impedance meter called GB11B. I didn't power this one up yet, so it's going to be interesting to do together in a minute. First, I've been looking a little bit on the front. So I got some multipliers for the impedance, and I can switch the meter between impedance, resistor, or the angle or phase. And I guess I can screw on here something between those two, though there will be a shield or a guard. I guess we don't need that one. We just put our components here, and I guess this is where we magnitude of either impedance or resistor, whatever it is you're trying to measure, and then you just dial these, and then you'll check on the meter when you have a dip. I guess this is a bridge and you're trying to get a dip or something, or maximum or something on the meter. But what I find a little bit funny, let's see if I can get a little bit of light here. Look at the numbers here. Look at the direction I dial. That is a little bit funny, isn't it? So I go this way, and then the numbers goes up. But on all other dials, I go this way, and the values goes down, right? And so this is the measuring current at sea level, remember? So I'm not at sea level, I am at 46 meters over sea level. So where is the compensation factor? How do I figure this out now? I don't know what to say about that. Is the current really that much pressure sensitive? So this is the angle. You will get a 25-degree angle. And this one I didn't figure out yet. Sine of phase angle, or I guess this has something to do with how aggressive the meter will be for angle, I guess. I don't know. This is just from 1 to 11 of what. And then plus minus, look at that. The dirt around those two buttons. Those are the buttons you really need to be pushing, I guess, because of course I can clean this up, I guess. Fuse, power, blah blah blah. So that will be the frequencies, right? 25 cycles per second, and all the way to 100 kilocycles per second. But you don't know where you are in between those, so maybe that is not so important. So this is just the amplitude of your signal. Oh, this one is super loose. This one is really tight. So this is the direct external generator. So we can use external input here for your frequencies, and then you can adjust for exact frequencies. What if you're measuring a system that is in a resonance, right? So of course you need an external. Oh, look at that. Polarizing voltage. You can add a DC voltage that will not affect your impedance measurements and stuff, but this DC voltage can apply voltage to a capacitor, and then you can measure what is the impedance change of that capacitor, for example, versus DC voltage, and that is very useful. Amplifier response. So we've got some different modes. Ground polarized. Balance to ground. How's going to? They don't really see. They're supposed to. Ooh, this one is the sticky one. Yeah, it goes up. I need to massage these a little bit before we'll get This is how it should work. So this I need to fix. Everything else seems to be working quite good. It also looks a lot like those are the two buttons you need to use all the time, and not so much that one, because this one looks new. Okay, this one is a little bit loose, yeah. But anyway, everything else seems to be in good. And again, okay, we're dialing counterclockwise. Oh, this one goes all the way around. There's no stop. Is that supposed to be like that? Those go. There's a really, really nice feel on those switches, especially this one. Wow, nice. I also like the way that the meter here is sunk into the front plate. That is really neat. So let's power it up and see if it blows the fuses. We also got really good stable handlebar handles on each side of the back panel. Whew. It's 21.4 kilos. And this is the funny old mains. What is in here? Ooh. What the heck is that? A little... Wow. Oh no, there's a plug-in module that is missing. Oh, is that important? Somebody took out something that goes in a socket here, right? Hey, and there's no text. You can then screw the module in, I guess. Okay, I don't know if this will be working or not without this module. But it also seems like when you mount this, you should be able to look through this and see that it is mounted. Damn it. So now it's getting funny. Mains is connected. 0 watts. Oh, I didn't turn it on. I'm an idiot. Okay, mains are now connected, and then... Oi! What? 5 watts. And this bulb is really sexy. Look at that. So let's go to resistor, multiplier 1. I put in 47 ohms. So this is the BLK flat. 1 kilohertz. 1 milliamp. Whatever that is. $47 watt. I don't see anything. What am I? Oh. Ah, come on, man. Ah, that was internal generator, right? Ah. So some stuff. Let's get some. Ooh. Oh. Oh no. Oh. Look at that shit. So that is the... Okay, maybe that is the external generator. What happens if I go to 0? Oi! What the hell? And now it's... Is that normal? Is this the indicator of some kind of funky stuff, or is it the power button? How the heck is that? This can't be. Because now I'm running on internal generator, right? I don't know, really. I don't see any No. No luck. Okay, it's because this switch is just, look at that. And then well, I don't know. I think we need there's poltergeist in this. Hello? I don't know where the I don't know where the error is. Is it just reading something from space, or is it, what is it reading? There is some sort of a, see? And it's not me talking, no. I mean, this thing is just not working at all. Maybe I'm just doing everything wrong. I have no idea. But this was with the... in a second there will be somebody putting in a comment. Hey, read the manual, you muppet. But that is the whole thing. The idea is I don't read the manual, and then I see if you can use these kind of instruments by just using common luck or common sense, or just read whatever is on the screen, and I don't know, you just can't. Okay, maybe we should consult the manual, because this, I think this is funny. And then the bulb goes on and off. Especially this is of course important, because I think we'll lose signal. We of course we need signals to have a readout out, right? As always with radiometer units, it's just super easy. You just pull out the 4 screws here in the corner, and then the whole unit just goes out of the casing, and then you can easily access everything. But this one got everything again inside a new case. But look at that. This is the power supply and signal generator. That is connected directly to the chassis, but the main unit, the whole big case here, is one big isolated. Isn't that sexy? We've got some cables going in between them. I don't know if I can. Maybe I can put a little bit of light down there. Yes, I can. But we've got other wires down there. I don't know, 2 times 4 or 5 wires. That's all we got in between those two. I think we should try and look a little bit deeper into those 2 cases. I took out all the screws. I think I did. Why aren't you not? It's just because it is so heavy. Are you coming? Oh. Whew. Oh, wow, what is that? That one is nice. We got some really cool. So there's a shield around that one. But where's all the electronics? We got 2 big capacitors and just those 3 little boards. That's kind of what we got in here. What are you doing? A pre-amplifier and the missing fantastic thing. amplifier and a board or something. AC input. Let's see what that is. This is the top where the meter is. Now we are looking down towards the 3 or 4 PCBs. So this is the pre-amplifier with 3 little transistors, or big ones actually. Missing plug-in module. There's an amplifier here with only 2 transistors. So this is the AC input and a rectifier and some capacitors, and so that's mainly the power supply. Maybe there's some regulation, but I don't really see it. All I see is AC input, rectifier, capacitors, and that says plus plus minus minus, so that will be your DC. It just goes, yeah, it just goes unregulated to the different boards. Oh, cool. So it's running. Really? So this is the mains input. Pretty funny with the way. And the on-off switch. Oh, there's a little rectifier down here. There's also a little... Ooh, is this any good? The bulb is completely loose. And the fuse, that is nice. Okay, great. What else have we got? Oh, hang on. So this is the oscillator side, where you adjust the frequency. I really like the feeling of this switch. It feels so stable and accurate. 0.5% resistors, and they even had to adjust a few of them. And this is a classic Wien bridge oscillator, because you got the capacitors right here and the resistors here, and then the bridge goes down to the oscillator. And I believe what I found down here is a little glass. Maybe we can see it. Let me find something. Yeah, can you see it here? A little glass component down there. That was most likely a bulb to stabilize the amplitude together with that transistor. So that will be the oscillator, a buffer, a power output. And that one, it says it's a filter choke. Look at that. 2 Henry, 15 ohms. So that is the DC input. And then we got some capacitors. See, this is the choke, some capacitors, and then it's power supply for the output stage, or this stage that's probably running off a really nicely filtered DC. So what we could do is just probe if this oscillator is running, because that will be very important for anything to work in this unit. And this is the external input. And it goes via some protection diodes, or are they resistors? They look a little bit sweaty. Okay, they are mounted in series. Probably for maximum input protection or something like that. Well, I think we should start measuring if we can fix this. And it's alive. This inductor is not the power supply inductor. No, it is the output choke. And the reason why this unit was absolutely crazy, that was the frequency range selector is just full of dirt, or is just not working. So when I turn this, see, no signal, turn it a little bit more, I get something. Some of the, see, if I just touch it a little bit, then I get something like this. So I need to massage this switch a little bit more, and then we'll see if we can measure something. But I think it is getting, see now, and then it comes and goes and comes and goes. It is definitely the oscillator that's the reason for all the problems. So while I was playing around with the oscillator here, I had it into some very unstable modes after some while, and it seems to be very temperature sensitive and supercritical. And what I did is I took my soldering iron and I heated up first the shield pins for the two transistors, and that didn't affect anything at all. So I knew by then it's not the two transistors here. And then I tried to hit the transistor, the casing, with the soldering iron just a little bit, and of course again didn't change the unstable behavior of the oscillator. But when I was playing around down here with my soldering iron, I went by this capacitor and just barely touched it, and then bada bing bada boom, output completely stable. So that capacitor here is leaky and it is affected by temperature. So that one we need to change. But of course I would really recommend changing all the capacitors because they're like 60 years old. And now when we got a stable oscillator running, I put the instrument in R for resistance. I put in 47 ohms, multiplier 1, and this is, can we show this? I don't know if we can see this, but this is 40. And if I see, go to 50, 40, it's almost nothing, and 30, I get full again. So what I think is we need to search for is a dip, and then you have found the right resistor. See, of course there is also a little bit of, you know, but anyway, we are in this, and I think there's something with this potmeter. It feels a little bit bad. But other than that, I think it can get up and running again if we change at least the capacitors in the oscillator, but probably also, look at that, it's exactly the same capacitors they're using in this instrument. So yeah, we need to change all of those. That is how it is. I didn't figure out the missing module. I don't know what that is. It says something about a filter. So if you know what that is it an option for something? Or has it something to do with this amplifier response? So that means if I go to selective, I use this filter. So I need to be in flat. Because see, there is no signal in selective mode. I need to be in. Okay, all the buttons, they need a little bit of massage. That is how it is. About this bulb. This bulb is mounted in between the two capacitors as like a voltage filter or a current measurement, voltage dropping. At least it's indicating when this unit is running or not. Because when you go for external oscillator, see there's a different current draw, and that will affect, see, that will affect the current usage. I don't know if this is easy to see on the video, but there's definitely something going on here with the different anyway, maybe we should go a little bit through the schematics as well. Did I turn off the mains? Probably a good idea when I'm poking around here with my fingers. So the mains transformator and the voltage selector, that is done here. So this is a secondary side transformator with some special shield windings in it. So the cable here is actually double shielded. The outside shield is connected to the chassis, but the windings here, they're connected to another shielded cable that goes through to the other board and to a rectifier. So that is how you generate a local, completely floating, balanced, isolated voltage. And then this voltage goes to a choke. That is this one. And then you get a DC voltage that is nice and clean. And this is used to supply all the real nice and critical circuits here. There are no voltage regulators or anything, so you just need very, very high inductance in series with your capacitors, and then you will have a clean voltage. Because this is a bridge circuit, so that means what the voltage is doesn't really matter so much as long as it's not full of hum. Let me see if I can document this. See, those are the ohms in this super special pot meter. And yes, it does work. See, if I turn it all the way down, it goes. Okay, now I'm touching my. So it goes all the way to 0 and to 11. Super smooth and accurate. So it really, really works. And here it is. Oh, let me see, can I get better down there? I don't know. So how the heck does this work? See, there is a slider that moves on 2 lines, and I think they got a little bit bigger diameter, but it also looks like metal. But I think there will be some isolation material and 2 thin wires going around here or something. So what you see here, all this brass you see, this is of course not connected. This is just holding the resistive element, or 2 thin resistor wires or something. But wow, that is special. It is just impossible to get this pot meter out because it is mounted in the, as you see here, in the internal casing. So I need to take this entire casing out, and it's going to take hours. But wow, that pot meter is just nice. I found out we could take a video from the back side. So now, look at that. We got some wires going around here, and they are most likely isolated, right? And they're connected to these two. Someone, maybe we can turn this. Oh, I can't. See, it goes around here. And when it goes to almost 0, then it flips up here and is shorted, and then it goes around and continues. Wow, what a lot of ingenuity put into this, with 2 wires that's isolated on top of some brass, or maybe the brass is coated with something, or wow, this is just so nice. They had to make this and think about it, because you can't just do it any other way, right? And that will be the 3 other knobs. They're of course made really, really nice as well. Yeah, another filter choke. Yeah, this is a beautiful instrument. What is in here? Just some shielding. Let me see. I want to know what is inside that one. So I believe this is the bridge inductor, because you see this is the test point, and it goes via the switches for different modes and stuff. And then there's this really nicely shielded inductor. This is well made, and this case is also super high quality, especially made for this product, of course.